Welcome everyone. Sorry about that. We are having our virtual meeting of the Hibiscus Coast Astronomical Society. So welcome to you all. It's going to be a relatively short evening tonight, I think. We're going to be kicking off with Josh, who will be doing his news, space news, and then we'll be moving over into the main presentation, which will be myself, and we'll be talking about this exciting new development on Venus. As ever, if you're on YouTube, just remember on that site, I think it is, you will see the chat box, particularly if you are on the desktop. If you're on an app, I think it is just below. So if you pop up there, say hello. That's also a place you can also ask questions. So it's going to be a bit of a strange one tonight because we sort of test out a new sort of way of doing things. So shortly I'll be handing over to Josh, who will begin, and then we'll have a bit of a transition and I'll start the main thing. So I'm going to jump up and let Josh sit down, and he can carry on.
Hi everyone, welcome, and as James said, thanks for coming along to our virtual meeting. So I'll be running us through the news first of all, and then I'll pass on to James for our main presentation tonight. So, astronomy news, what's been happening above us? So, firstly, Estée Lauder pays for skincare photo shoot in space. Now, I know this sounds pretty bizarre, and you're thinking, is this made up? But this is actually for real. So, the cosmetics company has paid NASA to launch 10 bottles to the International Space Station as part of a photo campaign for social media. So basically they want someone up in the space station to take photos of these so they can then post it on their socials, just to sort of build the brand. You might think this sounds a bit weird, but this is all part of a new NASA program that will devote 5% of space station activities to commercial projects. So the whole idea is that NASA wants companies to pay them for these sorts of opportunities, and that money will go to fund future deep space exploration projects. And at the same time, it helps raise awareness in the public about space and the International Space Station. So rest assured, no astronauts will appear in the photos, and the contract says that Estée Lauder can't say that NASA endorses the product or anything like that. And at this stage, they haven't even decided which astronaut will be taking these photos. That will be left up to the particular schedule, the workload, what they're doing. So I guess at some stage we'll just carve out an hour or so and get one of the astronauts to take some photos. And so I was thinking, oh, is this the first time that commercial products have appeared in space in a sort of product placement type way? And it's actually not. I did some looking into this. And back in 1985, we had Coca-Cola and Pepsi aboard the space shuttle. So this was an effort by Coke to get their brand in space, and they designed this special way to drink it, which they hoped would work in zero gravity. And before the launch, Pepsi found out, and they said, oh, we want in on this action as well. So Pepsi also quickly designed a zero gravity drinking mechanism and sent that into space as well, leading to these interesting photos of astronauts drinking Coke and Pepsi in space. And sticking with the theme of the commercialization of space, Space Hero reality TV show will launch Winner to International Space Station. So there's a new planned reality TV show where contestants, everyday people all around the world, are going to compete for a 10-day stay aboard the ISS. It's a pretty cool prize if you think about it. Now, they're targeting the launch date for 2023, so this is still very much in the early planning stages, and a lot could change between now and then. But the idea is that the contestants will undergo physical and mental training just to determine if, I guess, they're fit enough to go up into the space station. I'm sure there'll be a lot of other rules and things they need to sign. And this isn't the first time an idea like this has been proposed. Back in the year 2000, there was a similar idea for a reality TV show about the Mir space station. But unfortunately, that had to be scrapped when the following year, in 2001, Mir was deorbited. So yeah, watch this space. Lots of interesting commercial activities happening in space now. I also read something that Tom Cruise is in talks to look at the possibility of filming some action movie sequences on the International Space Station for an upcoming movie. I'm not sure if that has been confirmed as of yet, but yeah, it looks like there could be a lot of interesting things happening in future with NASA's new plan to devote 5% of space station activities to commercial activities. Next up, super-muscular mice could reveal a way to keep astronauts from losing bone and muscle mass. Now, we've spoken before about how with prolonged space flight, and if you're up in space for a long time, there's some health risks associated with that. One of the things is that when astronauts are in space, they tend to lose bone and muscle mass. This is because when we're here on Earth, we have the pull of gravity pulling us down, and our body has to constantly fight to stay up, basically. So when you're in the International Space Station and there's no gravity, the body can kind of relax. It doesn't need to use those muscles as much. And if you think about what happens if someone is in a wheelchair, for example, or bedridden, those muscles start to atrophy. And the same thing happens in space. But this news story is about something called myostatin. And this is a protein which was discovered in the 1990s in Johns Hopkins University. This particular protein limits muscle growth. It's something that's found in humans and other animals. And some experiments were done to see if we could sort of turn off that protein. And a lot of experiments were done on mice to find that if we block this protein, the mice can grow bigger muscles and more bones. But for decades, scientists have been wanting to test this in space as well. Well, last year they had their chance. A whole bunch of mice were launched to the International Space Station for an experiment. Some were normal mice, other mice had been genetically engineered to turn off that protein, and other mice had some special operation applied to them to kind of turn that off without editing their genes. But the long and the short of it is, what they found is that the myostatin inhibited mice retained more bone and muscle mass than other mice after 33 days in space. So in this particular photo, you can tell that the mouse that's closest to the camera is noticeably bigger than the other one. So I imagine that at the time of launch, these mice were the same size. But after 33 days in space, you can see that the rear one has shrunk. That must be due to losing the bone and muscle mass, whereas the other one has fared in a much better way. So this could lead to treatment for humans, but obviously there's a big asterisk about this. I mean, this is just mice. Just because it works on mice doesn't mean it will work for us, but it's promising results so far, and there'll be further efforts to see, can we use this in humans, not just for astronauts on long flights, but even for other humans. As I mentioned before, maybe people in a wheelchair, people who are bedridden for a long period of time. This could be a way for us to help keep those muscles and bones healthy in circumstances where they're not being exercised as much as they should. In other news, an ultraviolet aurora has been discovered on a comet, which was found by the Rosetta space program. So when we think about the aurora, we think about the northern lights or the southern lights here on Earth, those beautiful green sort of curtains that we see at the North and the South Pole. Well, we've now discovered that it's possible to have an aurora on a comet. Unfortunately, it doesn't look as beautiful as the ones here on Earth because it's not visible in terms of the sort of wavelengths. It's in the ultraviolet. So this was discovered by the Rosetta spacecraft, which was launched back in 2004 for a planned 10-year mission to study a comet. And you might recall a couple of years ago, it actually sent a lander to land on the comet, which is pretty cool. And we got a lot of interesting, useful information about this particular comet here. And at the time, we noticed this sort of shimmer, which you can see in the photo, a shimmer coming off the comet. And at the time, scientists thought that this was just the sun's photons. However, more research into these photos from a couple of years ago has shown, no, this is actually an aurora caused by solar wind. So this is interesting because it's the first time we've discovered an aurora on a comet. And it's interesting because this can help tell us more about solar wind and how that works. And here on Earth, our auroras are focused on the poles due to the magnetic field we have. That's why we have the northern lights and the southern lights. They're not present all over the globe. Whereas on this particular comet, they found the auroras more spread out because it doesn't have a magnetic field. And here is a GIF. It's a bit choppy, but you can see from this what that aurora looks like. And yeah, so initially scientists thought this isn't an aurora, it's something else, but we've now discovered this is an aurora on a comet. Also in the news, a new study of lunar rocks has boosted the giant impact theory of moon formation. So when it comes to our moon, there are a lot of theories as to how it formed. Some people think it may have formed within our solar system. Other people think it may have formed somewhere else and was traveling past and sort of got caught. But by far the most common theory, or I guess the most widely believed theory, I should say, is called the giant impact theory. And the giant impact theory says that around 4.4 billion years ago, another planet around the size of Mars probably collided with proto-Earth. And that would have sent up a whole bunch of material, which then over time was maybe initially a bit nebulous, but then slowly started to form into the two objects that we have now, Earth and the Moon. So this is our most widely believed theory, but it's still a theory at this stage. We're always looking for new evidence to prove that, because we don't know for sure that's what happened. But this new research has looked at lunar rocks. So these are samples of rocks from the Moon from the Apollo missions back in the 1960s. And with the new technology that we have today, we've been able to find some interesting things about the lunar rocks. Specifically to do with the concentration of chlorine, different types of chlorine. So when we think of chlorine, there are different types which are known as different isotopes. There's heavy and there's light. And this has to do with the number of neutrons in the chlorine. And what this study showed is that there's more heavy chlorine in the Moon than there is in the Earth. The thinking is that if the giant impact theory is true and there was a big collision, then over time Earth's gravity may have pulled more of the heavy chlorine to Earth, the light chlorine to Earth, leaving more of the heavy chlorine on the Moon. So when they discovered this, they thought, well, maybe this is just chlorine, but they've now looked at other types of elements as well, and they've found similar differences in other halogens. That's the same group as chlorine. They found that with a few different element types, we see that the heavier version of it is present in the Moon, whereas the lighter version of it is more common here on Earth. So this could be more proof that the giant impact theory is how the Moon was formed. Next up, small-scale gravity research wins big $3 million breakthrough prize in fundamental physics. So this is about researchers at a Seattle University who have built equipment to measure gravity at a very, very small scale. Now, of all the four fundamental forces, gravity is the weakest, and it's one that we're always trying to learn more about. And one of the things that we do know about gravity is something called Newton's inverse square law. And this states that the gravitational force between two objects is proportional to the square of the distance between them. So what that means is if you have two objects, they have a certain gravitational force that happens between them. If you double the distance between those objects, then the gravitational force will decrease by a factor of 4. So that's how the square law describes what the gravity should be at certain distances. And this is something that we've known about for ages, and we've been able to observe at the large scale and the sort of medium scale. But for years, physicists have been wanting to know, does this law hold up at the small scale as well, like the really tiny scale? Because if you know anything about the small scale, you know that once we go into the realm of sort of quantum mechanics and quantum physics, sometimes at those very small levels, the normal rules of physics don't apply. There are whole different rules and guidelines. So recently, these researchers have been able to use their equipment to measure gravity at this small scale, and they've found that Newton's inverse square law still holds up, even if the width between the two objects is only 52 microns, which is less than the width of a hair. I think a human hair is around 70 microns or so. So what they found is at that scale, this law still holds up. So this is good news to some. I mean, it means that we're learning more about gravity and how it works, even at small scale. But maybe it's not so good news for fans of quantum physics who are hoping that we might be able to find some really interesting things happening at a small scale that could prove the existence of extra dimensions or string theory or all of that. So yeah, unfortunately, we haven't found anything about that, but we do know now that gravity is even more stable and constant at that level. And finally, in the news, I thought I'd finish with this really interesting astrophotography photo. So this is the winner of a recent astronomy photographer contest held by Observatory Greenwich. And the title of this photo is Andromeda Galaxy at Arm's Length. If you have a look at this photo, you might notice that something seems a bit odd. It seems like it's really close to us. And this is because this has been taken using an effect called tilt shift, which is a way to adjust the lens of the camera to make the foreground and the background seem blurry, but what's in the middle is quite clear. And that's usually an effect that we associate with something that's close by. So it's interesting, just by adding this unusual tilt shift effect to the photo, the photographer has provided us with a very different view of our closest galaxy. So yeah, I thought I'd include this because it's such an interesting view of Andromeda Galaxy at arm's length. And that wraps up the astronomy news for now. That's what's been happening above us. So now I'll hand us back to James. So one thing you may notice in the news, I haven't mentioned anything to do with what's possibly the biggest news in astronomy recently, and that's about the thoughts that maybe there is life on Venus. I haven't mentioned that because that's what James is going to be covering in his main presentation. So I'll now hand over to James.
Okay, hi everyone. Just give me 2 seconds here just to change slides. And we are almost done. And there we go. So, you know, over the last couple of years here at the Hibiscus Coast Astronomical Society, one of the recurring themes is the possibility of life out in the universe. And we've had a look at a number of opportunities for life to develop within our solar system. So Mars being the big one. And of course we've got a whole bunch of Mars missions on the way to Mars to actually have a look for life on Mars. Some of them, that's the primary mission. We have a look at some of the moons around Jupiter and Saturn, so Enceladus and Triton, and we've pondered about the possibility of life in undersea oceans. And up until this point, we have not had much in the way of positive proof about life. But then out of left field comes this news that was dropped on us a few days ago to a week ago. Could there be life on Venus? And it's carried on about phosphine gas and a whole lot of things. And it was a little bit confusing. So what we're going to do is talk about it tonight and how amazing this is. And all of a sudden, on one of the most horrible planets to be in existence around our sun, where everyone thought that life could not possibly happen, there's actually a very, very strong possibility that life does happen on Venus. So let's have a little bit of a look through. Just a reminder, if you've got any questions, pop it into the channel. See Sandra and Jeff and John and Gillies, they're all in there. So pop up there, say hello to us as well. So let's have a look at life on Mars, life on Venus. So here we go. We're going to have a look first off at what is phosphine. Now, of course, the news was talking about the detection of phosphine gas in the clouds of Venus, and this is a precursor to life. So we're going to have a look at what this phosphine gas is, because most of the time when we look for life, we look for methane, we look for oxygen, a bit of carbon dioxide, much like life here on Earth. But phosphine, that's quite a new one. So we'll also be looking at so the cloud structure on Venus, very briefly, just to understand what the hell's going on Venus, and if there is life, where could it live? We'll have a look also at where did this life come from, because that's always a fascinating thing to ponder, even though we're not 100% sure. Let's have a look at that. And of course, how do we go about confirming that there's indeed life on the clouds of Venus? So first off, what is phosphine gas? So phosphine gas is a toxic gas, so very poisonous. It's made out of one phosphorus molecule and 3 hydrogen atoms. So pH 3, 1 phosphorus and 3 hydrogen atoms. So quite a simple one. There's a picture of it over here. So there's your phosphorus in the middle and with your 3 hydrogens. So it's a bit unassuming. So phosphine is amongst the stinkiest, most toxic gases on Earth. When you smell phosphine, you know that you've smelled phosphine, because it stinks worse than rotten eggs, worse than that sulfur smell. And you might be wondering, what on earth am I going on about? It's commonly called swamp gas, and this I find quite funny, because, in the old times with UFOs, the authorities were very quick to say, oh, it's swamp gas. So swamp gas is, in fact, phosphine, bubbling up from the bottom of bogs and swamps. It can also be found in penguin dung heaps. So if you pop down to Mission Bay, where the little penguins are, dig around in their dung heaps and you can have a sniff of phosphine. There we go. And you can even find it in the bowels of badgers and certain fish as well. So it is around and about, and you've probably smelt it somewhere around before, even if you didn't really know what it was. So most life on Earth, especially all aerobic, meaning oxygen-breathing life, wants absolutely nothing to do with phosphine. Either they don't produce it, generally, and they don't rely on it for survival. In fact, if there's a lot of phosphine around, they will die, because there's no oxygen for a start. So you must be wondering, what on earth is this very dangerous gas, and why is it a precursor to life? Because phosphine can only be made in 3 different ways. The first way is through anaerobic organisms. So these are organisms that do not breathe oxygen. So throughout our world, there are a number of these particular organisms that don't need oxygen. Some of them are found in the bottom of the ocean, next to those volcanic trenches. They don't need oxygen. They use different chemicals to form their food and their life. A little bit closer to life is if you are using fermentation to ferment foods. Generally, those are anaerobic organisms as well, so they don't need oxygen. Not all of them, but some of them. So these organisms are around. So phosphine is produced by these anaerobic organisms, such as bacteria and microbes, that don't require oxygen to thrive. That's a byproduct of them. The second way is it can be made by man in a lab. Quite easy. 1 phosphorus, 3 hydrogen, and away you go. There's phosphine gas. The third way is in the bellies of large gas giants like Jupiter and Saturn. So as you've heard in Chris's talk, Jupiter and Saturn are very, very big, and they have immense gravity and have immense power and temperature going on all the way through. And right towards the center of these gas giants is where molecules and atoms are fused together and then flung up back up to the surface of the clouds that we see as the planet. So in this way, yes, some of the gas giants can actually make some forms of phosphine, but not very much. So that will mean on Venus, phosphine cannot be produced in any other way except by these extreme oxygen-averse organisms, which make phosphine a pure biosignature or a sign of life. So, 1, anaerobic organisms can produce phosphine. Check. 2, can be made by man in a lab. No, there's no man-made phosphine there. It's not a big gas giant, so it's impossible to be made from this. But how do we know all of this? Well, this lady here, his name is Clara Sousa Silva, she's been actually working on looking at markers for life for about 10 to 15 years now. So she says, like, here on Earth, oxygen is a really impressive sign of life. Obviously, we know this. But other things besides life make oxygen too, because it's so pervasive in and around our part of the solar system. It's important to consider that stranger molecules that might not be made as often, but if you do find them on other planets, there's only one explanation, and that is the explanation of life. So let's have a little bit of a look at what she's been up to. So as I said, she's spent 10 years studying phosphine. Her team have looked at over 16,000 chemical candidates as biosignatures of life. Oh, spelling error there. So she's taken these 16,000 chemical candidates and she has researched the hell out of them. So they worked out the chemical pathways and the thermodynamics involved in a number of scenarios on Earth to see whether they could actually produce phosphine out of phosphorus. So they had a look at things like lightning strikes. Could the power of lightning create phosphine? And with all their research, the answer was no. Lightning cannot cause phosphine. So they went a little bit more extreme, and they had said tectonic activity, when two tectonic plates grind against each other, that power is actually enough to produce new molecules. Could moving tectonic plates create phosphine? So they did a whole bunch of research and they found no, that can't work either. So they had a look at all these different scenarios as to what can actually cause phosphine to be produced, and they came up with those 3 ideas. So phosphine, they found, has no significant false positives, meaning that any detection of phosphine on a rocky planet is a sure sign of life. So her conclusion is if phosphine is detected in a nearby rocky planet, i.e. Venus, that planet must be harboring life of some kind. So this is what she has said. The phosphine was produced in quantities similar to methane on Earth. The gas would generate a signature pattern of light in the planet's atmosphere. This you can detect as far as 16 light years away using something like the upcoming James Webb Space Telescope. So that is quite incredible. So what she says is, I think that the community needs to invest in filtering those 16,000 biosignature candidates down into some sort of priority. Even if we can get some of these molecules that are really dim beacons, if we can really determine that only life can send out that signal, then I feel that we found a gold mine. And this is what she's done with the phosphine. But she's saying, don't only look at phosphine, look at all the other elements as well. So moving on into Venus itself, there's a bit of a picture of what Venus looks like in terms of its cloud structure. So at the bottom over here, we've got all the gaseous hydrogen, helium, ammonia, water, all the regular things that you think of on a planet. So moving up into the atmosphere, just ignore this altitude because it's based on pressure. So moving up to about 50 kilometers up, we've got a layer of water ice. So clouds made of water ice. So pretty similar to what we get on a really cold day here on Earth when you look up in the very high altitude clouds. So above that we've got ammonium hydrosulfide ice, above that ammonia ice, and then we hit what's called the troposphere. Now the troposphere is quite an interesting one because it actually is quite cool in that area. In fact, about 27 degrees Celsius to about 200 degrees Celsius, depending on where you are on the planet. So there are areas that are actually like a nice summer's day on Earth that are up there. Moving up, you get the haze layer, which is just a sort of hazy gas, and then the stratosphere up towards the top. So we have all these different layers. So when we have a look at life, we have to have a look at where could this life exist on this horrendous planet, a planet where it's raining sulfuric acid and the pressure on the ground is so incredibly high, and the temperatures down there are very, very high. So where could this life actually exist? So if we have a look at this one here, I'll try and explain it. It's a little bit sort of different. So what they say is we've got this ambient flow of air, so wind basically, that moves across. As it hits a little outcrop, in this case like a little volcano on the surface, it gets forced up. So in this part of the atmosphere is where these little microorganisms could live. So as this air rises, it collects the spores of these organisms, which are down at the bottom here. Now these spores are in an inert state, so they're not actually technically alive and they're not technically dead. They're kind of like in a suspended animation. Similar to, if you remember, we talked about the tardigrades on the moon some time ago. Same sort of deal. So these things can sit for hundreds of years in this state. So what happens over here? They get shoved up in the atmosphere, right up, right up, right up, until we get to this like nice little warm spot up at the top. So at that point we find that water ice condenses out and starts forming liquid drops. These liquid drops will then mix with these spores and activate these spores. And once these spores are activated, they form the little microorganisms. Now these microorganisms can live up in this layer for quite some time, as long as they are suspended up there. So during that state, they will be able to um, divide up, form new little microorganisms. And that's where they'll multiply. So what will happen then is, as they move along and go through all this turbulent atmosphere, they'll start drifting down, because now they're getting weighted down with this liquid water, and the liquid water gets heavier and heavier, and it starts dropping back down into the clouds. Of course, once it's dropping down, it starts heating up, and of course the water evaporates off, and the little microorganism again turns into one of these little static creatures, which is neither alive nor dead. It's just sitting in suspended animation, and the whole thing all starts over again. So all the spores are sort of moving around, hit the airflow, move up, get caught in the condensation of the water that's up there, mix up together, get have babies, for the lack of a better word, and then slowly, as they start drifting down, they go back into their suspended animation, and back here to the spore state, and so it goes on and on and on. So quite an interesting thing. Now, of course, we don't really know that this is fact, because we don't even know that for sure that there's life, but this is the possible life cycle of these microbes. So there are three possible origins where this life could have come from. So one of the theories is the panspermia theory. Now, you've heard this one before as well, that a meteorite can crash into a planet. They then send the planet's rocks exploding out and hurtling into space. So occasionally those rocks will come crashing down on another planet. We've seen evidence of this where rocks of Mars have landed on Earth as meteorites. And we've also seen evidence of rocks from Earth possibly being on Mars. So obviously with Earth we haven't had significant meteor strikes, so these would have happened millions of years ago. But we've seen meteor strikes on Mars, and that debris eventually reaching Earth. So it is possible that there was life on Earth, a meteor crashed into Earth, exploded the rocks out. Some of those rocks drifted off down towards Venus and deposited life in the clouds of Venus. So quite a long shot, but it is possible. So a second theory is that life may have formed on the planet's surface when conditions were very different to what they are now. So a very long time ago, Venus was actually a more Earth-like planet, albeit a little bit warmer. So potentially had oceans and clouds and land masses. And then due to the runaway greenhouse gases, we had the greenhouse effect that took place, which caused the planet to heat up, and of course that's when all the oceans dried up, and things went from bad to worse, and how we know it now. So what they're saying is that life could have started all the way back then and just carried on through the evolution of Venus to live amongst the clouds. But there's a third one. The third explanation is to consider that a truly alien form of life, so life that, as we don't know it, could have formed on Venus's 400 degrees Celsius surface and survives there to this day. So such a foreign life couldn't probably be carbon-based, because nearly all complex carbon molecules all break down at extreme temperatures. We know this because of something like cremation. It doesn't take that hot a temperature and our bodies start breaking down. And it's the same for most creatures on Earth. We have heard of those extremophiles, the ones that live in the hot water vents and in the hot pools down in Taupo and Rotorua. But remember that those are those anaerobic ones. So they can tolerate heat a little bit more. But to have 400 degrees Celsius heat over a sustained period of time, it's very, very unlikely that carbon-based life could exist. Which means that if it's not carbon-based, could it be something like silica-based? Hence the picture there, which I'm sure all you Marvel fans will know what that is. So although the carbon-based life produces phosphine on Earth, it's impossible to say that only carbon-based life can produce phosphine. So it is possible that maybe a silica-based life or some other form of life could do it. So there we have three different possibilities of where life could have come from on Venus. So how do we confirm all of this? So the only way is to actually go there. So as it happens, there are two space missions that have received funding to go there. So nothing final yet. So there's phase A funding came for Veritas. So that's the Venus Emissivity Radioscience InSAR Topography and Spectroscopy. Veritas. So basically it's got two instruments and it's got a 2-year mission. It'll be in low orbit around Venus. And basically what its mission is to understand Venus's geological evolution. Wants to also see what is also going on currently in the geology of Venus, and it needs to find evidence of water either in the past or present. So it's not really geared to finding life, but it's quite early in the mission, so I'm pretty sure that they can add in something else to have a look at the possibility of life in the clouds of Venus. I'll bet my money on the second mission, which is called the Da Vinci mission. That's Deep Atmospheric Venus Investigation of Noble Gases, Chemistry and Imaging. So Da Vinci. So Da Vinci is already there to study the chemical composition of Venus's atmosphere. And how it's going to work is like you can see it there. It's going to parachute down. And as it goes through the atmosphere, it will be sampling the air and returning measurements down to the surface or back up to the spacecraft. So those measurements are important to understand the origins of Venus' atmosphere, how it evolved, and how and why it is different from Earth and Mars. So this is really important for us to understand where life could be lurking. And of course, if they're sampling the air, they could probably add in something there which can look for microorganisms or sort of other forms of life. So Da Vinci's measurements would also reveal the history of water on Venus. Again, this is this fixation we have on water equals life and the chemical processes that work in the unexplored lower atmosphere. So that was shortlisted on the 13th of February 2020. So again, nothing firm yet. Of course, these two missions are probably going to get a huge bump because of what is actually going on with this absolutely amazing news. So just to wrap up here, does Venus have life? So we've had a look at phosphine. So phosphine can only be made by 3 different ways. 1, man-made. 2, in the bowels of big gas giants. And 3, by anaerobic microorganisms. So does Venus have life? Well, it looks that way because of the phosphine there. Of course, there's another explanation that perhaps Venus and its extreme sort of atmosphere and extreme environment might be producing phosphine in a different way. Of course, that's always a possibility as well that we need to look at. But at this stage, phosphine on a rocky planet equals life. We've had a look at the clouds of Venus, that there are different layers, and the upper layers are quite nice in temperature, so could support life as we know it. And of course, because we know of the extremophiles here on Earth, those that live in very hot and very cold, a lot of microorganisms can adapt to quite horrendous conditions. So could they be living in the clouds of Venus? Quite possibly. We had a look at 3 different origins of life. One, could it have got there through a meteor crashing into Earth and sending it along here? In fact, I think I posted a study the other day on this exact question, and the study has said that it's almost impossible that that could have been the case. There wouldn't have been enough biomatter to produce the signatures that we are seeing in Venus currently. So that leaves, is it a new alien form of life on the surface? Chances are no, because as we say, all life that we know of is carbon-based, and the carbon-based life probably wouldn't survive in that hostile planet side. So what's left is this anaerobic microorganisms, which could have sort of lived there since the time of water and oceans and a beautiful atmosphere on Venus. And it looks that could possibly be where it is, which does, of course, make this a proper extraterrestrial life, i.e. not from Earth. And we've had a look at different ways that we can confirm it, mostly by going there and actually looking at it ourselves. So Chris has said there it's good to see future missions are planned for Venus. I quite agree there, Chris, and I think with this announcement with the phosphine and the great possibility of phosphine actually indicating life, I think we could probably see quite a few more missions scheduled in that direction in the next couple of years. What is interesting is that we've always had a look at life and said, oh, life has to have oxygen, life has to have this, life has to have that. Water, liquid water is essential for life. Whereas we're finding here on Venus, well, maybe, yes, it is essential, but not quite in the way that we thought. So we're talking about little micro droplets of water that is evaporating and freezing and turning liquid quite quickly. So as the scientists were saying as well, there's 16,000 other candidates that we need to look at as well to see whether there are biosignatures of life. And if we go through that list, life might be a bit more abundant than we thought, and in the most unexpected places, like in the clouds of Venus. So if you have any questions, just pop it over there into the chat. And we're going to keep an eye out on this because it's really fascinating. I think this is probably the biggest announcement in terms of astrobiology that we've had in many, many decades. In fact, if this is proven to be correct, this is just sort of blows the whole of astrobiology out the water, because it's life in a place that we really didn't expect it to be. And let's have a look and see. So, any questions there? I can't see any there. So what I'm going to do now, just as a little bit extra, if I can do it, I'm going to have a look at what is happening in the night sky, if I can get things to run properly here. So if you give me 2 secs, I'm just launching Stellarium. There we go. Okay, so right at the moment, if we have a look at our night sky, we'll begin here in the east. So coming up is the moon over there, and if we fast forward a little bit, okay, there we see Mars coming up. So if any of you have gone out in the last couple of nights, you will have seen a bright red star out in the east, and a couple of people have asked about it on the channel on Facebook. That is Mars. And why is Mars so big and bright and red at the moment? It's because Mars is in opposition. So what does this mean? It means that we've got the Sun, we've got the Earth, we've got Mars all in a straight line. So basically Mars is at its closest point coming up, I think it's the 21st of October to Earth for the next little while. So if you've got yourself a nice telescope, it doesn't have to be particularly strong. You can go out and you'll be able to see the disk on Mars. If you're lucky, you might be able to see some of the polar ice caps, particularly in the north, or what we see as the north top bit. If you've got a little bit stronger, you might see what used to be called the canals of Mars, which are quite interesting to see. If you've got a really, really good telescope, sort of an 8-inch or so, you'll be seeing a lot more detail, some of the clouds. The last time Mars was in opposition was during the big Martian dust storm. So most people actually couldn't see much to do with Mars, other than a big dusty disk. But currently it's looking good. Also coming up in October, we've got a meteor shower as well. But sort of I'll give you news on that a bit closer. So having a look around, some of the nice big shiny stars out there, Achernar and Canopus are also coming up. So the brightest stars in the sky. Move around, there is the Southern Cross with the pointers over there. If I put on the constellation lines, there we go, and the labels. So there we go. So there's the Southern Cross, and so this is looking at about 9 o'clock tonight. So I'll take it up to about 10. So that's at almost about 10 o'clock. You'll see it's starting to drop down a bit. If we have a look, sort of up in this neck of the woods, you'll find Omega Centauri is up that way. So moving along a little bit more towards the west, then we've got Scorpio. with Antares, another nice big red star out there. So have a look for Antares, and then you can follow the tail of the scorpion. Always a nice one to show your family and friends, because it's quite an easy one to spot. And of course, sort of coming over to summer, this is our nice little summer constellation. So moving back around, we've got Altair up here, another nice big bright one to have a look at. Heading to the north, there's the Pegasus system, the head and the hooves, the legs, the back end. Look a bit higher up, you'll see right almost directly overhead, we've got Saturn and Jupiter quite next to each other. Let me zoom in a little bit there. So pretty close. Jupiter, of course, very, very big and bright, and also bright but a bit dimmer just above it will be Saturn. Of course, really good to have a look through your telescopes. Even looking at Jupiter with your binoculars is pretty good, because what you can do, if I zoom in a bit on Jupiter here, you will be able to see those 4 moons. So Ganymede at the top, Io, Europa and Callisto. And these are quite easily seen with your binoculars. In fact, probably easier to see with binoculars because of the field of view. So you'll see one big bright star and the 4 little sort of fainter stars, those are the moons. So if you've got some good binoculars, that's another fantastic one to show your friends and family, because most of them have only ever seen 1 moon in their life. Now, in one night, they can see 5. So the 4 moons of Jupiter, as well as, of course, our own moon. So that's pretty good. If we have a look at Saturn, if you've got a slightly bigger telescope, nice one to see, because you could actually see the disk like that. And if you look very, very carefully, you'll probably see Titan as well, depending on your telescope. So some very interesting things there to see. If I'll move out again, and let me call up the deep sky objects. There we go. So quite a few deep sky objects around. There's the Omega Nebula over here. In fact, if you follow the entire Milky Way across, there are so many nebula to be seen. It's quite hard sometimes to differentiate which one is which. But some nice ones to see. Wishing Well cluster over there. So it's a open star cluster, a really pretty one. There's Jewel Box, another really good one. If you've got some really good binoculars, you can actually see the Jewel Box with that. Let me see if I can zoom in on that. There we go. So of course this picture doesn't do it much justice, I'm afraid. Go and have a look, with a small telescope, and like I say, if you've got decent binoculars, and you'll see a pretty awesome different colors that are there. There we go. There's my favorite one just over here. So there's the Southern Cross up here. So just to the right and down, that's the Omega Centauri globular cluster. This is easily seen. Some people can actually see this with the naked eye. I've seen it with naked eye, but with glasses. So it is possible. This whole thing is about the size of the full moon. So it's a pretty big object in the sky. It's just it's very faint. So grab your binoculars, even some really sort of lower grade binoculars, as long as they can magnify, you'll be able to see this awesome globular cluster here. Really well worth seeing. There's a whole bunch of nebulosity over here, the running chicken over there, the Carina Nebula over here. Pretty awesome looking. Just having a look where the Carina Nebula is. Oh, there's another nice one, Southern Pleiades. So if we go back here, there's your Southern Cross. To the left of it, you'll go past that little nebula there, and you hit the Southern Pleiades. So the Southern Pleiades, this isn't Matariki, but it kind of looks like Matariki when you look at it through binoculars. It's quite awesome. It's one of the first ones that you should see with binoculars. Oh, there's a little satellite going past. So that's the Southern Pleiades over there. Again, much better when you actually look at it in person. A bit lost here. So quite a lot actually in that Southern Cross region. I say go further along the Milky Way. There's a lot of nebulosity up here. There's a beautiful little one there, Prawn Nebula. So it all depends on kind of what telescope or what binoculars you're using. This is another interesting one, the Butterfly Cluster. A little bit harder to find, but it's quite pretty if you ever look at it. It's an open star cluster, quite a number of stars in there, and so that will be, if we have a look, zoom out a bit. So if you look in the west, go directly up. To the left is the Butterfly one. There's the Omega Nebula over there. You need a bit more of a telescope to see that one, unfortunately. Summer Beehive is another one that you can have a look for. Sort of a smaller telescope will be able to see this, binoculars as well. Bit of a little open star cluster over there. So it's all looking in the western direction. So moving up again back to north, there's Cygnus all on the horizon. M15 over here, so it's a globular cluster. You'll need quite a good telescope to see that one. Of course, most things in this area are going to be wiped out because of the moon and the glow of the moon. And here we go. So, there we go. Small Magellanic Cloud. Most of you, I think, know how to find that. So, go south and then just to the left, so south-southeast. Small Magellanic Cloud, and there 47 Tucanae. Another nice, beautiful globular cluster, well worth looking at. You can see this through binoculars as well. And that's kind of what we're looking at there. Really awesome. Several hundreds of thousands, if not millions, stars all in one little cluster there. Of course, there's your Magellanic Cloud. Also quite awesome to see. It's of course what we call a dwarf galaxy that goes around our own galaxy. So when you're seeing the Magellanic Cloud, you're actually looking at a different galaxy. And of course, you've got to realize we're lucky down here the southern hemisphere, because the northern hemisphere people don't ever get to see it. And they don't get to see 47 Tucana either. So we are quite lucky with that. Anyway, thank you all for joining us this evening. And if you want this program, by the way, it's free. It's called Stellarium. And if you just search for it, you can download it. And of course, you can see what's in the night sky directly. You can look ahead till tomorrow, the next day, a week from now. You can go back 33,000 years if you want to see what the night sky looked like in ancient Egypt. And so quite fascinating there. So quite a good program. I think most astronomers use it. And then, of course, use your phone apps as well. That's pretty important when you are out and you actually want to have a look up there. Thank you again for joining us this evening. And hopefully the next meeting we'll be back to our normal regular meetings. But if not, we'll see you back here. Of course, keep your eye out on the Facebook page or the emails for those who don't check Facebook, and we will be letting you know what is happening there. So I'll say good night to everyone. Thanks guys. I hope you guys have learned something. I certainly learned a lot doing the research on this. Good night.